All right, Unit 3, Day 5. This is the last day of this unit. So after this, we're going to do some reviewing, got a quiz, and then some reviewing and a test. So we're kind of wrapping everything up here. So the equation forms of parabolas, we have three different equation forms. I can change, our learning target is I can change vertex form into standard form and standard form into vertex form. You know, we go back and forth with that. And the way we do that is that we can do factored form also. So first off, just remembering, maybe pause and think for a second. Can you remember what vertex form looks like and what standard form looks like? So vertex form, if you remember, it's going to have ax minus h squared plus k, okay, where that vertex, it's screaming it at you, that's the h and the k. And then there's the standard form, y equals ax squared plus bx plus c. Okay, and on this one, the vertex is going to be negative b over 2a comma f of negative b over 2a. So once you find this number, take negative b over 2a, get a number, plug it into the function, that's your y. Also, the y-intercept is c, which I should say 0 comma c. We'll make it an ordered pair. Factored form we didn't say a whole lot about, but we will see in the future, we'll start working with it. But factored form is when you write down the factors, like what two binomials did we multiply to get this standard form. So it'd be, if a is a 1, we'll have like x, and then we'll have minus r1 minus r2, where these r's are the roots. Okay, so these are the x-intercepts would equal r1 comma 0 and r2 comma 0. Okay. Now, converting vertex form to standard form is probably the easier way to go. It's not, basically you're just going to do your order of operations and simplify it. So like here, this says to, like we're supposed to add 4. Well, we can't add 4 to x, but then it says square and then subtract 2. So we're going to square it first. And keep in mind, when you square, when I take x plus 4 squared, that's like x plus 4 times x plus 4. I've got that minus 2 on the end, but I'm going to do this first. And when you do it, make sure you FOIL. We want to FOIL, so FOIL. So first, you got x squared. Outer is a 4x. Inner would be a 4x. So notice anytime we're squaring something, this number gets used twice, the 4, because it goes there and there. So it's going to get multiplied by x twice. So 4x and 4x. That would eventually be 8x. And then the last term is going to be the last, so 4 times 4 is 16. Okay, you got that minus 2, we got to drop that down, so y equals x squared plus 8x plus 14 would be the standard form for that. Okay, keep going, so on this guy over here, same thing. We're going to square it first, because you can't subtract 1 from x, nothing to simplify, so we're going to square it, multiply it by a negative 3, and then add 5. And we'll get something that looks like this in standard form. So I'm going to have x minus 1 times x minus 1. First I'm going to write it like that so I can FOIL it. So first would be x squared. Again, we said we're going to have a x times negative 1 and then an x times negative 1 again. Because since it's being squared, it's the same binomial twice. So negative 1 and negative 1 make negative 2. When you're adding them, and now multiply negative 1 by negative 1, you get plus 1. Okay, next step would be to distribute the negative 3. Don't add yet, distribute the negative 3 out. So this would be negative 3x squared plus 6x minus 3, plus the 5 on the end. So y would equal negative 3x squared plus 6x plus 2. So that would be that equation in standard form. Now going the opposite direction is a little bit more tough, a little bit more to it. The big thing here, we're going to be looking for a pattern. And I kind of tried to point the pattern out up here, but we're going to work backwards. So I want to convert from this to that. So let's take a second here. This is just some extra, so you can get in the corner of your paper if you want to do this with me, or just watch. I'm at x plus 1 squared. That's x plus 1 times x plus 1. So, in the kind of pattern there, I want to take x times x is x squared, and then when I do my outer, which is 1x, and my inner, which is 1x, it's just that 1 twice. So that number is twice this number. We're going to see if that holds up. And then the last would be 1 times 1, which is 1. Here I've got x plus 2 times x plus 2. Okay, so first is x squared. Again, when I do my outer, that's 2x, and so is this. So it just got doubled. That 2 got doubled, so 2x and 2x make 4x. Notice 4 is twice of 2. And then the last one is going to be 2 times 2, which is 4. Happens to be 2 squared, and that's 1 squared. Let's keep going. First would be x squared. Outer is 3x, inner is 3x. Again, same thing. Okay? So that would be 6x. And then the last is going to be plus 9. So look, 6 is double 3. 9 is 3 squared. Okay? See if it keeps going. So x plus 4 times x plus 4. I got x squared. Outer is 4 times x. Inner is 4 times x. So 4x plus 4x is 8x. And then 4 times 4 is 16. Double 4, square 4. So do you think maybe if I double 5 and then square 5, would that be the answer? Let's try it out. So first would be x squared. Outer is 5x, inner is 5x. 5x plus 5x is 10x. And then last is 25. Okay. How's it going to change now I got negatives here, though? Is it the same pattern? Let's try it out. So let's double this. What's double negative 3? Negative 6. What's negative 3 times negative 3? 9. Let's see if it works. You're on edge, aren't you? Suspense right now. So x times x is x squared. That's a negative 3x. That's a negative 3x. Negative 3x plus negative 3x is negative 6x. And then negative 3 times negative 3 is 9. So I could almost just see that this is a shortcut here. This is going to be double negative 4 would be negative 8. Negative 4 squared is 16. X squared, double negative 5, that's negative 10. Square negative 5, that's a positive 25. So it's like if we had x minus, we could just say that this is, we just call it a for now. The shortcut would be, it's going to be x squared, and then it's going to be double that. It's minus 2 times a plus a squared. This will always be plus because you're squaring something. So whether it's positive or negative, it doesn't matter. Now if I did x plus a squared, x squared plus 2a plus a squared. Now, when we go in the other direction, though, when we're converting here, we're doing vertex to standard form, we want to find one of these and work backwards. So what if I told you that I have x squared plus 16x plus 64, and I said, what binomial squared did I multiply to get that? What number did I double to get 16, square to get 64? 8. Or what if I did, let's do 20x plus 100. Okay, so what did I double to get 20? And square to get to 100? Well, 10. Okay. Now the thing is, not always is this perfect. Okay. So what it is, you're taking half of 20 to get 10, and then you want to see, is that actually 10 squared? And it is, in this case. What if I had, say, plus 8x minus 4. Is that minus 4, is that going to be something squared? So what double gives me 8? 4. But is 4 squared equal negative 4? No, so those are not equal to each other. Okay. Video froze here. Those are not equal to each other, so not true. What would make it true, though? What would I need to put on the end here so that this does equal x plus 4 squared. So double 40 at 8. The pattern was square this to get that, so that needs to be a 16. If this was, I'm trying to think of one you haven't seen yet. It's going to be pretty hard to do. But what number needs to go here to make this equal a binomial squared? So what number doubled give you 4? 2. 2 squared is 4. So if I put a 4 there, that would complete the square. This would be a perfect square trinomial then, because a square. And you think about perfect squares, like if I told you 1, 4, 9, 16, 25, 36, what's so special about those numbers? Well, you recognize those numbers. What makes them so special is that they're a binomial, or that they're a number squared. 1 squared equals 1, 2 squared equals 2, 3 squared equals 9. 2 squared equals 4. 4 squared equals 16, 5 squared, 6 squared, and so on. So just like these numbers are familiar to you, I'm hoping eventually we can get these perfect square trinomials familiar to you, and you can complete the ones that are necessary there. So the kind of the trick was to find that number. I took half of this number, half of it, and then I squared it to find that number. Okay? So I'm going to try to continue that idea over here. So we're going to have, we have this ax squared plus bx plus c. Well, we really want that c, we want that to equal half of b. So this really needs to be half of b squared. If that's true, then this is going to equal a perfect square trinomial. It's going to equal x plus half of b squared. It'll be a perfect square trinomial. So maybe something that kind of looks weird. It's okay. We're going to try to get through it. So this is sort of a difficult idea, but we can do it. So I need to put this in a vertex form, which means I need to have a binomial squared somewhere in there. Is 3 the right number? So is 3 the number that makes this equal to some binomial squared? And in this case, it's not, because half of 6 squared would be that number. Okay, so what I'm going to do to make this happen, negative 3 is not my guy. So I'm going to push him. It's going to push him to the right a little bit. Put negative 3 here. What number do I want to be in there? So what number would work? I don't think I did it on this one. But what number? So I have x squared plus, minus 6x plus what would make this a binomial squared? So half of 6 is 3. 3 squared is 9. So 9 is the one I want. 9 is that guy I want, so I need to add a 9 here. Problem is now, this is an equation that balances out, and I just added 9 to the right side. So this is no longer a true statement. So if I add 9 here, I got to subtract 9 over there. That way my net gain was 0. So the right side of the equation gained nothing. When I added 9 and then subtracted 9, it didn't change it. Okay? Now, what binomial squared equals this? Again, the trick was half of this number. And then over here, I've got negative 3 minus 9 is negative 12. And then how could I check myself? So it says prove it by expanding the algebra. So I'm going to take this guy, y equals x minus 3 squared minus 12. Let's multiply that out. X minus 3 times x minus 3 minus 12. So this would be x squared minus 3x is minus 6x, and then plus 9. X squared minus 6x plus, minus 3, which is what the original problem was. So now I know I did it right. So this is the vertex form of that. Okay? All right, so let's go to the backside. And maybe I'll just do a few of these since we're getting, the video is getting kind of long. But again, I'm going to take half of this number and square it and see if that's the right number. Okay? So I guess I should say we're going to put it in vertex form and then sketch it. So is 11 the right number? What's half of 6? And then squared? Half of 6 is 3. 3 squared is 9. 11 is not my guy. He's not the one I want. So I'm going to push them over to the side, push 11 over, put the number in that you want. I want 9, because half of 6 squared is 9. But since I just added 9 to that side of the equation, I have to undo that by subtracting 9. That way the net gain is 0. Okay? So this would be what binomial squared? So what would I have to double to get 6 and square to get 3? I'm sorry, to get 9? 3. So there's vertex form. Okay, now if I were to graph this guy, how did I get 20? That's a 2. Good grief. Okay, so my vertex is at -3, 2. It's at -3, 2, so right there. And then because this is the A is 1 here, I can just go up 1, right 1, up 3, 1, 2, 3, right 1, up 3, right 1. And there's my parabola, which I can kind of check myself. The y-intercept should be at 11. I'm pretty sure I'm going to hit right on 11 when I get up here. That's probably a pretty good indication that I'm right. Okay, this guy here is at -4, the number I want. So what's half of -2? It's -1. Now square that, it's 1. So 1 is the number I want. Okay, so I got y equals, I'll put x squared minus 2x. Push the -4 off to the side for now, put them over here. And then put in the number you want. So half of -2 is -1. -1 squared is 1. Since I just added 1, I got to subtract 1. Got to make it fair. Okay, so that would be, I got a binomial squared. Over here I got -5 hanging out on the end. But what binomial times itself would equal this? The trick, divide -2 by 2, so -1. So the vertex would be at 1, -5. So 1, -5. Sorry. And again, the A on this one is a 1. So nothing stretching here. There's no vertical stretch. So up 1, right 1, up 3, right 1. If I look at standard form, the y-intercept was -4, and that's what I got down here. So that verifies it. Let's see here. So I've got y equals, I know that's not the number I want. Right now it's a +0. That's not the number I want. I could push 0 over, but there's really no reason to write it, so I'm not going to write it. But what number do I want that to be? Half of 2 is 1. 1 squared is 1. Undo it on the other side. So if I added 1, I got to subtract 1. Now what binomial squared equals this? So it's always just half of that number. Half of 2 would be 1. Okay, so the vertex is at -1, -1. Again, just a normal, no vertical stretch, so it's just up 1, right 1, up 3, right 1, mirror them over. Something like that. Okay. Maybe I'll pause there for now. And please don't forget to down here, update your learning log. Okay, we're going to have you submit those. If you haven't already, we need to have you submit your, or share it with me, and you are going to submit your final copy then on Friday through Canvas. So if you've already submitted, we'll have to do it again on Friday. So but make sure you complete it. And it's only going to be helpful for you if you do it along the way. We don't want you to, like, on Friday, fill the numbers in. It's not going to help you at all, but yeah, so do it along the way and see if you can use it as a tool.